So, 2.14 from Advanced Higher Maths Camp, parametric equations. Although not so much dealing with parametric equations, that's easy enough in its own. It's really about dealing algebraically with the expressions that result from it, taking out common factors, dealing with fractions within fractions. Parametric equation in that each of the variables is expressed independently in terms of a parameter t. So that we've got x is t squared minus 1 over t squared, and y is t squared plus 1 over t squared. So to get the derivative, first derivative first, I can only differentiate x with respect to t. So that t squared would become 2t, that's power negative 2, so I'll be plus 2 over, and I'll drop to negative 3. And symmetrically, this would have to be 2t minus 2 over t cubed. Then, to get the first derivative, I want dy by dx. Well, I can't differentiate y with respect to x. It's only got t's. So I'll have to differentiate y with respect to t. And then, by the chain rule, function of function, multiply by the derivative of t with respect to x. So that would be dy by dt, 2t minus 2 over t cubed, which in itself isn't that bad an expression, but it'll be times dt by dx, which is the reciprocal of this. So it'll be 1 over that. The space here, I'll just put it underneath. So over 2t plus 2 over t cubed. Now it's not looking so nice, but it's actually very simple to get that sorted out. I've got fractions within fractions. All I need to do is multiply every term by whatever it takes to get rid of these nasty fractions here, get rid of the t cubes. So multiplying by t cubed will sort that out. At the same time, everything divides by 2, so I might as well divide by 2 while I'm at it. So dividing by 2 knocks out all the 2's. Multiplying by t cubed, that would become t to the 4, minus just 1. T cubed cancels out t cubed, and we've already divided by 2. Multiply by t cubed, t to the power 4, plus 1. We've already divided by t cubed. So that's the first part. There's the first derivative. Right, for the second derivative, I want to differentiate dy by dx again. That was dy by dx there. But it's expressed in terms of t, so I can only differentiate it with respect to t. And then multiply that by the derivative of t, as in the chain rule, with respect to x. Now I need enough room, have I got enough room to the side? I'll just do it underneath. So, differentiating this with respect to t. Now I've got the quotient rule. I've got the denominator, square it, and then the top follows the same pattern, apart from being minus, as in the product rule, whereby no matter how many products there happen to be, you cycle through them one at a time. Differentiate the first, leave the rest alone. Differentiate the second, leave the rest alone. Differentiate the third, and so on. So, differentiate the first, and I've got 4t cubed, leave the other one alone, t to the 4 plus 1, move on to the next one, leave the first one alone, t to the 4 minus 1, multiply by the derivative of that next one, times 4t cubed. But at the same time, I'll need to multiply that by the reciprocal up here. So that'll be 1 over 2t plus 2 over t cubed. Now I'm not so sure if I've got enough room at the bottom, so I'll just get rid of this stuff at the top here. And then carry on up to the top. Equals. Now, for this part, I've got common factors of 4t cubed, so I can take that out. 4t cubed, that was very handy. And that leaves me with a t to the 4 plus a 1 minus a t to the 4 minus 1, so that's minus t to the 4 plus 1, minus t to the 4 plus 1, all over t to the 4 plus 1 squared. While I'm at it, I'll sort out this fraction, which can be dealt with independently. That's a separate multiplying fraction to this one, so multiply all three parts by t cubed, and that will sort it. So I'll have t cubed over 2t to the 4 plus 2. Right, whilst I'm tidying this bit up, I've got 4t cubed times t to the 4 minus t to the 4 disappears, plus 1 makes a 2, all over t to the 4 plus 1 squared. Then I've got, why I paused there, this part here, I've got another t cubed. I can take out the factor of 2, so 2 times t to the 4 plus 1. That's very handy, because that's going to match that and give me just another power here. That 2 could cancel out that 2, so that would just leave me 4 t to the power 6 all over t to the power 4 plus 1, that's squared plus another 1, cubed, which gives me the second derivative.